Doppler effect. Basically, Doppler effect in the simple language, we always like to use a simple language. Doppler effect is related with the sound frequency because of the relative motion of the listener and the sound source, the frequency will change. The frequency change. This effect is called Doppler effect. So they applying this Doppler effect into what? Into astronomy, because of the relative motion of the planet, so that the light wavelength be shift, usually shift to the blue, so they call Doppler shift. Okay. So in us, we will in the final, we will definitely have one question is come out from Doppler effect. Total Doppler effect homework-wise have a two Doppler effect homework and one example. So we need to address that during the review before the final. So the final is, I think, is February 18 or something like that. Okay, February 18 is on Thursday. So you have a lot of time to do the work, because we're going to finish chapter 15 tomorrow, and so forth, and we will catch up. So again, the Doppler effect is not that many people understand by talking about it, is how to explain this complicated effect, make it understandable. So we usually like to use a car, automobile. See, this automobile is traveling. It carry a sound source. So this sound source, and sound source both way, right? One go to the front, one go to the back. So sound wave originally is travel like this. So sound wave is like an ocean wave. This is when v, the speed of the vehicle, they have a meaning on that. That is the velocity of the source. The velocity of the source. Velocity of the source equals 0.0. So this is the sound wave travel. And the sound wave travel is in here, in this way. So when the velocity of the source is stationary, so consequently the wave length no change. So now we go to the speed of sound. Speed of sound is considered as equal to v. The velocity of sound is equal to v, and then that is equal to f times lambda. So now using the things that you know, frequency times wavelength is equal to speed of sound. And then you're using another simple algebra term, equal velocity divided by the lambda. So again, is simple algebra. This simple algebra is very important for you to know when the wavelength is going down. Wavelength is going down. So the frequency is increased. So according to this equation, frequency equal velocity divided by lambda. When the lambda is getting smaller, something constant divided by something smaller, the frequency is increased. Now, if the wavelength is larger, and then frequency is decreased. Now, this is simple logic. You don't even have to go to the derivation and auto jazz, and then even the high school T or the source is not equal to 0. Well, we're using different color. The velocity or source is not equal to 0. And in these cases, we move forward. So when the sound wave moves forward, so that this is sound wave moving forward, and then it is have an effect called compression the wave. So this wave is compression. So in these cases, when this compression goes, according to this, you see the wavelength is getting smaller. So in these cases, the wavelength is getting smaller. So when the wavelength is getting smaller, according to this, the frequency is going to increase. Okay. Now, from this is from the front. Now we like to say from the back. When this sound source moving forward, so the wave is slowly diluting like this. When it's diluting, what it means the wavelength, each crust and trough is getting larger. So lambda is become larger. So in these cases, the frequency is become smaller because the wavelength is small. So that is the doubling. Now, the gentleman, this effect actually you can hear if you have good ears in the physics. I think 1B classes, they do this experiment. Somebody hitting this and walk, and hitting this and walk. This is considered one of the good experiments, but it's a very, very subjective experiment. What we're going to use it is for a lot. If you are speeding, doubling effect. Doubling effect is because of the policemen are using the ultrasonic sound generator, sending the sound beam and hit your car, and then the sound return. And then by the relative motion, he can determine, and of course with the microprocess in his car, then he find out that how speeding you are, how fast you are. So a couple places you don't want to get speed. One is the 57 freeway. But because of 57 freeway, you go way up and you're downhill, go to 60 freeway. Holy smoke, very easy, 80 or 90 miles per mile, per hour. I think I get 2 tickets from there. And then the policeman say, give me driver's license. I said, I'm teaching at PCC. He says, sure, I'm doing good about United States. Doesn't care who you are. If you get a ticket, you gotta pay, or go to classes. One of the mayor from West Covina, he got a ticket. He keeps saying, I'm West Covina mayor. West Covina mayor. The police say, sure, I'm doing my job. Please give me your driver's license. That mayor was on the news. Of course, I'm not on the news. So anyway, that's the type of thing. So we like to give you a formula to finding out the frequency change. So original frequency is F. And then after the motion changes, so the F prime is equal to F times V is speed of sound plus V relative motion V sub O means observer. V sub O is observer speed or listener speed. And then V minus V sub S. S is source of the sound. Source of the sound. So V is speed of the sound. Speed of the sound. Speed of the sound. In these chapters, so there's an example 13.7. It's a very good one, and the only thing lacking in this example is no drawing. So you have to draw your own. Draw the diagram accordingly, like what I drew there. And that one is a very good example. And then the other one is two doubling effect problem. One is 35, another is 37. So the teacher gives you the hint. That means among these three, two homework and one example, we could pick one for the final. Is it that easy? So